Well, let's now look at the base catalyzed hydrolysis of an ester, and here we're going to use H2O and OH minus, and we're going to use H plus in the second step to get neutral compounds at the end. Alright, so let's look at how that goes. And again, we can see it's going to follow the negative mechanism, and we can see that the Y group will be this one here, and you can see that this will be the X group, which will be the OH, which will have a negative charge on it, and there's our X group here, and here is our Y group, and it will initially be Y minus, which will end up being converted into YH at the end because we're adding H plus in the second step. Alright, so let's look at the mechanism, see how it goes. So the OH negative will come in, and remember that it's always the charged species that will attack if you've got a choice of two, because it's always the least stable of the two. Okay, electrons jump up on the oxygen. The negative charge comes down, kicks out the leaving group, and we end up getting the O negative here as well. Well, here we've reached a little bit of a complication. We've formed a carboxylic acid, but it's a carboxylic acid that is still in a basic solution. I want you to realize that at this step we have not added the H+, and we cannot add the H+ yet because we haven't finished doing what we're doing with these reactants. So what's going to have to happen is, in the basic solution, this will always be deprotonated. Something will deprotonate it. Something will take off that hydrogen. We've got a choice of two things to take off the hydrogen, actually. The first one is the actual leaving group, the O negative. That can take a hydrogen, and that will give us this alcohol as a product, and then we'll get the carboxylate ion here as well, and then we can add in the H+, and the H+ will protonate it, and we'll end up getting our other product. Now remember, this only happens when we form a carboxylic acid in a basic solution. It doesn't happen at any other time. Let me show you the other possibility that we can have here. Instead of having the O negative take the H here, what we can do is we can have the OH here, and then we'll have the O negative down here. And instead of the O negative taking the hydrogen, we can actually have the OH negative from the solution take the hydrogen. Remember, there's always going to be excess base here, so that is a possibility. And we'll still have the compound here with the O negative on it that we haven't done anything with yet, and then we can add H+. Now remember that when we add H+, it's always enough to neutralize the solution, or in this case make it more acidic. So we end up getting two neutral products at the end. I think this first one is a little more likely, only because the O negative would be right there next to the carboxylic acid as soon as it formed, and then it would swoop in and take this hydrogen off the carboxylic acid straight away. But this is also possible, and I'm okay with this as being a mechanism as well. But it's very important to realize this happens because we're forming a carboxylic acid in a basic solution.